In the last lecture, we were talking about the characteristics of scalar product. Let's move on to the remaining properties, remaining characteristics of scalar product. How do we resolve vectors? Vectors का resolution कैसे करते हैं हम? You can take component of a vector along any direction. सिर्फ ऐसे हॉरिजॉन्टल और वर्टिकल ही चाहिए ऐसे नहीं है. फॉर एग्जाम्पल, सपोज दिस इज अ वेक्टर ए, एनी वेक्टर ए, एंड यू वांट इट्स कंपोनेंट अलोंग दिस लाइन. इस लाइन पर आपको इस वेक्टर का कंपोनेंट चाहिए. व्हाट यू कैन डू देयर? ड्रॉप अ परपेंडिकुलर ऑन दैट लाइन so that this will be component of A along this direction. ये वेक्टर क्या है? A का कंपोनेंट इस डायरेक्शन में. अगर ये एंगल है थीटा, if this angle is theta, then what will be this component? This component will be A cos theta. So if this is vector A, this component will be A cos theta. So you can find out the component of a vector in any direction. If this is a vector A and this is a vector B, there are two vectors, vector A and vector B, and suppose theta is the angle between them. From the head of the B, if you drop a perpendicular on vector A, then what is this vector? ये तो है वेक्टर A. ये वेक्टर क्या है? This is B cos theta. This vector is B cos theta, means this is component of B. This vector B cos theta is component of B in the direction of A. Vector B cos theta is component of B in the direction of A. Getting the point clearly? So what we did, we took component of B in the direction of A, that is B cos theta. Now coming back to dot product. What is A dot B? By definition, A dot B is AB cos theta. So dot product is equal to A into B cos theta. A into B cos theta means dot product of two vectors. Dot product of two vectors is equal to the product of magnitude of the first vector, magnitude of the first vector, and magnitude of component of second vector. B cos theta क्या है? Component of second vector in the direction of the first vector. So the dot product of two vectors is equal to the product of magnitude of the first vector and magnitude of component of the second vector in the direction of the first vector. That is the next characteristic of scalar product or dot product. In the resolution of vectors, we saw that any vector A can be written as resolution into three components. So any vector A can be written as IAX plus JAY plus KAZ. Similarly, vector B can be written as IBX plus JBY plus KBZ. That is what we studied in the previous lecture, resolution of vectors. Using this resolution, A dot B will be equal to what? A dot B will be equal to dot product of these two, means IAX plus JAY plus KAZ dot IBX plus JBY plus KBZ. Agreed? That is equal to. Now you will multiply them one by one. We'll open the brackets. So first we multiply this with this. I dot I into what? AX BX. इन दोनों का मल्टीप्लीकेशन देखो बराबर है क्या? I डॉट I इंटू AX BX. फिर इसको इससे मल्टीप्लाई करेंगे प्लस I डॉट J इंटू AX BY. I डॉट J इंटू AX BY प्लस अब इसको इससे मल्टीप्लाई करेंगे. So it will be I dot K AX BZ. So you multiply this quantity with every term. Now similarly, we'll multiply this with every term. So this will be plus J dot I AY DX plus J dot J into AY BY plus J dot K into AY BZ. Is it correct? Plus, I will multiply this with every term. K dot I into AZ BX. K dot I into AZ BX plus K dot J into AZ BY plus K dot K into AZ BZ. Correct? We open the brackets. Now this will be equal to. What is I dot I equal to? In previous characteristic we saw I dot I is equal to 1. So I dot I is equal to 1. 1 into AX BX, that is AX BX plus what is I dot J? I dot J is 0. So 0 into AX BY will be 0 plus I dot K. I dot K is again 0. So this whole term will become 0 plus J dot I is also 0 plus J dot J 1. So 1 into AY BY, that is AY BY plus J dot K again is 0 plus K dot I 0 plus K dot J 0 plus K dot K 1. So 1 into AZ BZ, that is AZ BZ. So A dot B is equal to AX BX plus AY BY plus AZ BZ. So this is the next characteristic of dot product. A dot B is equal to AX BX plus AY BY plus AZ BZ, and this is very very important property used everywhere. Calculations में, derivations में हम इसका यूज करते हैं. A dot B is equal to AX BX plus AY BY plus AZ BZ. So that is, I think, the sixth characteristic of dot product. And the last characteristic is not actually a characteristic, it is an example of dot product, that W is equal to F dot S. Work is dot product of force and displacement. Force is a vector, displacement is a vector, and work is a scalar. So work is dot product of force and displacement. So these are the characteristics of dot product or scalar product.